Hello, grade 7. This is your math video for lesson 2-7, page 94, numbers 3 through 25, all of them, as we go through these today. I'm sorry, but I do want you writing these problems down while I write them down, and be ready to show them to me as part of the assignment, okay? So let's see how many we can get through as quickly as possible. Right here we've got an r attached to this number by subtraction, and we want to make it equal to 4.32. How are we going to get r by itself, Mr. Ponko? Well, what is the opposite of subtracting that 7.81? If you said adding 7.81, you'd be right. We got to do that to both sides of the equation, add 7.81 to both sides. And if we do that, on this side, we're left with just an r value because this cancels this out. But the big question is, what does this equal? I don't know. Let's write it right here, and let's add the two numbers together. Don't forget to line up the decimal points when you're adding or subtracting. That's very important. I get 12.13. 12.13 is my answer, and we're going to move on to the next problem. Okay, let's look over here. X is attached to the 7.2 by multiplication. What's the opposite of multiplying by 7.2? Well, how about dividing by 7.2? And remember, we have to do it to both sides of the equation, right? We're doing it to both sides. We get x over here, I don't know what that equals, so I'm going to have to do the long division. 7.2 into negative 36. Well, remember what we do with this. If we got that decimal point, we got to move it over one spot. So 7.2 becomes 72, and 36 becomes 360. Don't forget it's a negative 360. So our answer, let's try 5. Let's see what happens. 0, 1. Hey, it works. The answer is negative 5. Don't forget, it's got to be negative, because a negative divided by a positive is always a negative. Okay? Let's try this fractional one here. Now, be careful. We're not adding or subtracting fractions here. We don't need common denominators. This is a multiplying problem. We only need common denominators when adding or subtracting. We don't need them with multiplying. So, what's the opposite of multiplying n by negative 2/3? The opposite of multiplying n by negative 2/3. Wouldn't that be dividing by negative 2/3? Yep, it would be. And when we do that, we get n on one side. Do you remember the rule about dividing fractions? To divide, we multiply by the reciprocal of the second number. And when we do that, we get 9 over 10. And that's our answer on that one. That's our answer. Okay, don't forget to pause this if you need to, but I'm going to move on to the fourth problem. There she is. What's the opposite of adding this to g? Wouldn't that be subtracting it? Yes, it would. From both sides, over here we're left with g. I don't know what that is, so I'm going to have to do the subtraction. Don't forget that when you're subtracting, you've got to line up the decimal points. And we get, this is a 5 and this is a 12. Oh, I'm going to have to borrow from this to make this a 15. 7. I get 0.78 is my value of g. 0.78. Is that on the screen? Yes, it is. Okay, if you need this, pause it. If not, I'm moving on to the next problem. Now, this one is a little bit different than this problem. This one up here was multiplication. This one down here is a subtraction problem. So yes, I'm going to need common denominators for this. What might be the common denominator? How about 15s? 5 times 3 is 15. So negative 4 times 3 is negative 12. 3 times 5 is 15, so 2 times 5 is 10. Okay, what's the opposite of s minus 10 over 15? Isn't the opposite of subtracting this going to be adding it? Yes, we're going to add 10/15 to both sides of the equation. I'm wondering if this is on the screen. Let's take a peek here. Yep, it's still on the screen. Over here, the 10/15 both cancel each other out, leaving with the s. Over here, I'm going to have negative 2 over 15 as my final answer, because negative 12 plus 10 is negative 2. All right. Let's look at this one right here. So we got x times 7/11. What's the opposite of multiplying by 7/11? Well, isn't it dividing by 7/11? And wouldn't we have to do that to both sides of the equation? On this side, we're left with x. How do we divide fractions? Isn't the rule to divide, we multiply by the reciprocal of that second number? And I'm going to make negative 21 into negative 21 over 1. Hey, there's some simplifying we can do here. Divide by 7, divide by 7. Divide by 7, we get 1. Divide by 7, we get negative 3. My final answer is negative 33 in that problem. Is that showing up there? I think so. So that's 6 problems. That's 6 problems. If you need to pause, pause. If not, I'm moving over here. Don't panic. We got another 9 problems over here, but I don't think I'm going to do all 9. I think I might just do 3 more for a total of 9 problems. So when you're ready for math class, you should have 9 problems written down. Okay, let's look at this one right here. X times 9.7 equals negative 67.9. What's the opposite of multiplying x by that 9.7? Wouldn't it be dividing by 9.7? And then don't we have to do that same thing to this other side? You betcha. Over here, multiplying and dividing by 9.7 leaves me with x. Big question is, what does that equal? I don't know. Well, let's do the long division over here. 9.7 divided into negative 67.9. Wait a minute, I can't do that. It's got one of those decimal points, so I'm going to move it over and make that 97, and move this one over and make it 79. How about, I don't know. How about 6 times? Let's try 6. That's 58. That seems a little low. Let's try 7. 9, 4. Hey, it works out perfectly. The answer is 7. But is it positive 7 or negative 7? Well, a negative divided by a positive is a negative. So the answer to this is negative 7. How about this next one? Subtraction. Now remember, if we're subtracting or we're adding, we're going to need common denominators. Down here, when we're multiplying or dividing, we don't need common denominators. So here, what's going to be our common denominator? How about sixths? What number would 1/3 be if I changed it to sixths? Aren't we multiplying by 2? So we multiply by 2 and we get 2, right? Next issue. How are we going to get x by itself? What's the opposite of subtracting 2/6? Isn't the opposite adding 2/6? Yes, it is. So I'm going to add 2/6 to both sides. I get an x value equaling whatever this is. This is negative 3 over 6 or negative 1 over 2. And that's our answer, isn't it? Negative 3 over 6 is the same thing as negative 1/2. If you need to pause, go ahead. If not, here's my last problem. 4/9 equals 8/11 times A times A. What's the opposite of multiplying by 8/11? Isn't it dividing by 8/11? And don't I need to do that to both sides of the equation? I certainly do. On the right side, it just equals A. What about on the left side? How do we do this? Well, isn't division of fractions the same thing as multiplying by the reciprocal of the second number? Sure is. Is there any cross simplifying we can do? How about divide by 4, divide by 4? Don't we get 2 and 1? And so the final answer is 11 over 18. 1 times 11 is 11. 9 times 2 is 18. So that's a total of 9 example problems. 9 example problems. Hopefully this helps you. Make sure you have them all written down by math class.